In question 8, we're given f of x is equal to the quantity x squared minus 3 all squared over x cubed, where x cannot be equal to 0. In part A, we need to show that f of x is equal to x minus 6x to the minus 1 plus 9x to the minus 3. The question carries 2 marks. What I'm going to do is expand the bracket in the numerator and then cancel terms. So we'll have now the f of x, expanding the numerator, we'll have x squared, which will give me x to the 4th, minus 3x squared minus another 3x squared, which is minus 6x squared, and then we're going to have minus 3 squared, which is going to be plus 9. All of this now is over x cubed, or x to the power 3. Splitting this up, we've got f of x. We will do this term by term. X to the 4th divided by x cubed, minus 6x squared over x cubed, and then we're going to have plus 9 over x cubed. We know that x to the minus n is equal to 1 over x to the n. And using the rules of indices here, we've got now x to the power of 4 divided by x cubed will just give us x to the 1st. We've got x squared over x cubed, which will give us minus 6 over x, and then we'll have plus 9 over x cubed, and we can just write this in the form that they want. You could argue that you don't need this line right here. 2 marks in total. I'm going to just add it to be safe, and then we can write now that this is our final answer for 2 marks. In part B, it says hence or otherwise differentiate f of x with respect to x. The question carries 3 marks. So all I'm going to do is pick it up at this stage. So what we can say then is f dashed of x, the gradient function or first derivative. If we differentiate x to the 1st, we will get 1. We're going to multiply down by the power, and we're going to drop the power by 1. We're going to multiply down by the power, and we're going to drop the power by 1. And that will give us now that the gradient function f dashed of x for 3 marks is 1 plus 6x to the minus 2 minus 27x to the minus 4. Again, you could argue to show workings here for the full 3 marks. I'm going to write it in this particular form, but if you want to show the full workings, you can do.